All right, so the last lesson that we had was 521, where we identified arithmetic and geometric sequences. And today we're only going to look at the arithmetic ones, and we're going to look at, what type of sequence is it? How do we know it's that type of sequence? And how can we write the equation? Also, is there any other way that we could be looking at the sequence? So sequences have their own notation and vocabulary that help describe them, such as term and term number. So the term number is saying, like, I'm on term number 1. So term number 1 is -9. Term number 2 is -5. Term number 3, and so on. Sequences always start with term number 1. They never start with term number 0. When we are describing a sequence, we're always going to start that way, even though we will sometimes need the 0th term, which won't be on here, in order to write the equation. So first we want to look at whether or not this is arithmetic, geometric, or neither, and how can we tell? So the first thing we're going to look for is there a difference that stays constant? So from -9 to -5, that's a +4. From -5 to -1, I wrote 5. That's a +4. From -1 to 3, that's a +4, +4. So it is a constant difference, the change. So not necessarily subtraction. It could be addition or subtraction. So this one's arithmetic. And we would say, how can you tell? We can say the generator is +4. We can also say there is a common difference. So different ways to look at it, I guess. What is the first term of the sequence? So -9 is the first term. When the sequence generator adds a number to each term, the value that is added is known as the common difference. It is the difference between each term and the term before it. What is the sequence generator? So in this case, we are adding 4. And if it were getting smaller, we would say to add a negative number. You're not going to hear us talk about subtraction in a sequence. So it's either adding 4, or if it were decreasing, you might have add -4 if that were the pattern. Record the sequence in a table. Remember, a sequence table compares the term number n. So we've got, 1, 2, 3, 4, 5, and the value of the term number. So like this is the result. It's kind of like when we had function notation f of n, it's the output. So if we're on term number 1, the output or the value is -9, -5. I'm copying these from the sequence itself. So the sequence is always generated from that outcome y column, t of n, f of x kind of column on the second one. Graph the sequence. Should the graph be continuous or discrete? Sequences are discrete because terms are discrete values. So discrete terms are discrete values. Okay, so this is the first, this is the second, this is the third. We don't have an in between because we don't have like a 2.5 term number. So when we go to graph it, we would say 1, -9. So that would be right here. And then 2, -5, 3, -1, 4 would be +3. And then 5 would be +7. And I would not connect the dots because it is discrete. How is the common difference related to the graph? The rate of growth is also the slope, is also the common difference. Because we are increasing +1, +1, +1 in the first column, then it is a +4 over a +1. So it's a rise of 4 over 1, or your slope. So the rate of growth is equal to the common difference is equal to the slope or the rate. They're all interchangeable, except for my handwriting, which is very poor. Write an equation to model the sequence. So this sequence is arithmetic. It's going to follow that sequence that we've been using for the past 2 years, which is like the y = mx + b. Now t of n is our output, and you'll notice t of n is here at the top of the table. So we would start with t of n equals, our slope was 4, and we're using n instead of x for the input, so 4n. And then we would need the 0th term to be our plus or our minus here. So we kind of need to think like, what was the term before the first term of the sequence? So if we were going, +4 +4 to work our way down, we'd have to subtract 4 to get the one that would have come before it, which would have been negative 13. And so we would have 4n minus 13. What is the domain of the sequence? So the domain is x values. It is all positive integers. We said when we write a sequence, we don't start with 0. We always start with 1. So positive numbers only. And it's only integers because we don't have like a 1.5 or a 2.5 in here. So positive integers, sequences start at n equals 1. That's because it is a sequence. If it were a sequence equation, just the equation and not the actual sequence, the equation only would be all real numbers. And what I mean is I can plug in any value of n. I can plug in 16.234 and get an output. So if I'm just looking at the sequence equation in and of itself and not thinking about the graph and not thinking about the table and where the equation came from, I can plug in anything for my domain. But because it's a sequence equation and we are specifically talking about a sequence of numbers, I only have positive integers. It always starts at n equals 1. So what's the t of n? What's the output when n was 0? So back right here when we went backwards one spot, when n was 0, we said the outcome was negative 13. So when t of 0, if we plug in 0 for n, or we look for the 0th term, the output was negative 13. And how is this value represented in your equation? We can say it's the constant. We can also say it is the y-intercept. Or you can say, and I'm not even entirely sure that I spell this right myself, but the zeroth, I guess I can take the shortcut there and use the th for 0th term. So if we went back 1 and we went to an input of 0, the output would be negative 13. All right, so if we go on to the back, throughout this course, initial value, starting point, or 0th term will be used for t of 0 when you plug in 0. And this number will not be listed as part of a sequence. T of 1 is always the first term, and it's the first number listed in the sequence. T of n is called the nth term of the sequence. So let's start with 0th term. What was the 0th term? Like, what's the one that would come before negative 4? Well, in order to do that, we've got to figure out the other parts first. So negative 4 to negative 1, the difference is 3 plus 3, negative 1 to 2 plus 3, 2 to 5 plus 3. So common difference would be plus 3. The first term would be negative 4 because it's the first one listed in the sequence, which means if I went plus 3 to go to the right, I'd have to go minus 3 to find the one before it, which would have been negative 7. So if I write an equation for t of n, that would be common difference of 3 means the slope is 3, so 3n, and the 0th term was negative 7. Verify that your equation works for each of the first 4 terms. Now, if you look at the printout and you look at my copy, you can see all of them. But just for example, if I wanted to do the 1, 2, 3, let's say I wanted to do n equals 3. 3 times 3 is 9. 9 minus 7 is 2. And we should have gotten 2 according to the sequence. But all 4 are on the hard copy that you already have that's filled out. C, is it possible for t of n to equal 42? So what we're looking for is it possible for the output to be 42? And not the band, the B42s, sorry. Plus 7 on both sides, 3n equals 49, divide by 3, divide by 3. Now here's where we need to think about what we said about the actual meaning of a sequence. And the values of n can only be positive integers. So when I do 49 divided by 3, am I going to get a positive integer value of n? And everybody should be shaking their heads and saying, no, Mrs. Frazier, because 49 divided by 3 is not a positive integer. So you would say, no, why not? Solution must be a positive integer. For the function f of x equals 3x minus 7, is it possible for f of x to equal 42? Now, notice we've switched to that f of x, which is the function notation, has nothing to do with the sequence. It doesn't have n. It's not attached to the problem before it. It's just a function in general. The answer to that one would be yes, sure, why not? We just solved it, and we would get x equals 49 thirds. The function has a domain of all real numbers. I should say this function because it's not all. This function has a domain of all real numbers. All right. Explain the difference between t of n and f of x. And make sure that you sort of, think about why b and d are different. Or I think I should say b and c, but the difference, t of n is a sequence. It is limited to positive integers only because it is a sequence. And then f of x has a domain of all real numbers because it is a function. So t of n is a sequence and f of x is a function. And this one, n has to be positive integers, where on this one, x is all real numbers. All right, Trixie wants to create an especially tricky arithmetic sequence. She wants the 5th term of the sequence to equal 11 and the 50th term to equal 371. That is, she wants t of 5 to come out to be 11 and t of 50 to come out to be 371. Determine the common difference. Now, because we know it's an arithmetic sequence, that tells us a couple things. It tells us that it's linear. It tells us that it has a common difference. So that really means, can you figure out the slope? So we're saying, can you figure out the slope if you have a point 5, 11, and then you have another point 50, 371. And the reason you can do this is because it's arithmetic, because it's linear. So I can do 11 take away 371 over 5 take away 50. You also could have subtracted them in the other order if you were thinking of the points backwards from how I've got it. You would get negative 360 over negative 45, which is positive 8. Negative divided by negative is positive. And then you could find, so let's determine the common difference. It would be plus 8, right? Plus 8, plus 8, plus 8. That's because 8 is our slope. The initial value would be your b. So y equals 8x plus b. And I would plug in, I'm plugging in 511 because that's going to leave me with much smaller numbers to work with. 11 equals 40 plus b. If I subtract 40 from both sides, I get negative 29 equals b. So that was minus 40 on the right, minus 40 on the left. So my 0th term is negative 29. And the equation for this sequence, because it's a sequence, we'd have to say it's t of n equals, think of that as your y. Think of that as your y equals mx plus b. That's your output. 8 has to be n because it's a sequence instead of x, minus 29. 7 years ago, Cody found a box of old baseball cards in the garage. Since then, he has added a consistent number of cards to the collection each year. He had 52 cards in the collection after 3 years and now has 108 cards. How many cards were in the original box? Is this t of 0 or t of 1? That's the first question. And then write the first few terms of the sequence. So the first thing we want to look at is 7 years ago, Cody found a box of old baseball cards. So let's see, 7 years ago, since then he's added a consistent number. He's got 52 cards in the collection after 3 years and now has 108. So I've got to think about this question. 7 years ago, Cody found a box of old baseball cards in the garage. So this is 2020. So 7 years ago would have been 19, 18, 17, 16, 15, 14, 13. That would have been 2013. So 7 years ago would have been 2013. All right. Since then, he has added a consistent number of cards to the collection each year. He had 52 cards in the collection after 3 years and now has 108 cards. Okay, so I'm going to look at this and say 52 cards after 3 years, 0, 1, 2, 3, 52 cards, 4, 5, 6, 7, that's the 108. Okay, so I'm saying 7 years ago, that's here. That 7 years ago is going to be your, nope, that's your now value. So for that one, for us is going to be 2020. So 2021, 2019, 2018, 2017, working my way backwards. So there's your 7 years ago is your year zero, your 0th term. So I'm going to say, how do I find the slope? I'm going to have to do 108 take away 52. And then I'm also going to do 7 take away 3, which is 4. So 108 take away 52. I'm getting, let's see. Oh, I added to this. How many cards were in the original box? That's way back here. Haven't gotten to that question yet. 108. I'm actually doing this with you guys in case you're curious. 108 take away 52. But you're probably not curious because I'm taking a long time. It's 56 over 4, meaning that the generator is 14. So if I do 108 minus 14, I get 94. Minus 14 is 80. Minus 14 is 66. And minus 14 would be 52. Minus 14 would be 38. Minus 14 would be 24. And that would get me back to 10. So how many cards were in the original box? 10. Is this T of 0 or T of 1? It's T of 0, original. Right, the first few terms of the sequence. So the sequence always starts at term 1. So the sequence would start at 24, which is really strange, right? It doesn't start with the 0th term. It starts with the first term. Cody plans to keep the collection for a long time. How many cards will the collection contain 10 years from now? So if we look at our equation, we're saying T of n equals, we found that the difference was 14, so 14n. We found the original or 0th term was 10, so plus 10. If I want 10 years from now, right now we're in the 7th year, so 10 years from now would be 17. So I would do 14 times 17 plus 10. 14 times 17 is 238. Plus 10 would be, and this is, I was plugging in 17, so technically this is T of 17 equals 248. So 10 years from now, he would have 248 cards. So the equation, I wrote it up above, but T of n equals 14n plus 10. What does each number in your equation represent? We said that 14 was the common difference, also known as the slope. And 10 is the 0th term or original number. And that's it. So the big deal here on sequences is that they always start with n equals 1. They always start with term number 1. You will need the 0th term to write the equation. And because it says arithmetic, because we know that there's a constant pattern, we can use this with slope and slope-intercept form. So hopefully you have some questions for me to get clarified when we get to class. See you then.